Let's see. Is my camera working? There it is. Um, a okay. Actually, today is not going to be. Today, I'm not feeling so good. I didn't get any sleep last night, so like, oh, I'm not going to be on camera today. Um, okay, guys, welcome. So today we are going to continue with our deeper dive into the 18 dimensions. Um, and today we're going to be talking about tone, or, we some know it as sound. Um, I do want to go back just to talk about all the dimensions in general for 1 second, because tone is actually one of the special ones. So, like, and I need to share my screen here first to um, point something out to you guys. All right, we're going to share that image. All right. All right, you guys see the periodic table there? Okay, so okay. So in general, um Walter Russell's science concept is all about mass going from the inertial plane to accumulating potential till it reaches that maximum point, and then going back to return where it came from to plane. And as Walter shows in his periodic table, this cycle, or this happens over and over again. And he's got it broken into octaves. And so, since we're doing tone today, part of today, we will be using music as kind of an explanation. And, he has his periodic table broken up into what he calls octaves. And for those of you who are musicians or familiar, I always say, look at the piano. You've got 88 keys on a piano, and they all have a different pitch from, lowest to highest, when you go left to right on the keyboard. And so when we look at these octaves on the periodic table, um, essentially what's happening is it's repeating the same pattern over and over again from the first octave all the way to the last octave. If we just look at one octave, let's look at our favorite octave, the fifth octave, where carbon is. You know, you've got helium, and it goes up the potential plus one, plus two, plus three to the 4, 4, and then minus one, or sorry, minus three, minus two, minus one, and back to the, well, in this case, the next inert gas, neon. And then it just keeps doing that same thing. So the octaves repeat. The Each octave is its own cycle. Okay. And we've all talked about that before. We understand that. Now, all of the 18 dimensions, except for two of them, will repeat in each octave, will repeat its cycle. For example, we talked about color. We talked about, well, here's an easier one, is plane. The idea of plane, that if you are starting here at helium, the plus one is one angle. The plus two is another angle, all the way up to the plus four, which would be 90 degrees to the initial helium inertial plane. And so that plane, it will basically just go up to 90 and then back down to zero. Then it'll go up to 90 and then back down to zero. So the dimension of plane, like all of the other dimensions, except for two of them, will just repeat. So the two that are special that don't repeat are mass And what we're going to talk about today, tone, because mass and tone, instead of repeating, they just go all the way through the cycle. They start, so mass will start at the first octave and just go all the way up and just be increasing all the way up until the last octave, the 10th octave or the ninth octave, depending on which table you look at. I'm using the 1926 version of the universal one here, which he later changed to 9 octaves instead of 10 octaves. Okay. Scott, you had your hand up. Sorry. I
I
see
have
your
a
hand is up.
question.
Yes.
So
What's the
going back to
question?
any of these octaves, right? We
Yeah.
know that the 4/4, like in carbon, is at 90 degrees.
Yes.
What are the degrees of the +3, +2, and +1?
Ah, okay.
I don't think they're equal.
So I tell you what, I am at the end of this session, this 30-minute session, when we're on our little break, when we come back, and before I start the next recording, there is something I will show you guys that will explain to you what you just asked. But um, I just have my reasons. Just put a pin in that, and we're gonna come back to that. Okay. Because I have something for you. But I have my reasons not to share it right now. Um, okay. So sorry about that if I was breaking up. I'll just a quick brief recap. Basically, I was just saying, that Walter has broken up um the periodic table into octaves, and all of the dimensions just repeat their same pattern or cycle, if you will, in each octave. Like it does a pattern in one octave, and then it goes to the next octaves and the next octave, and then it just does the same pattern that it did the octave before. Okay. Um, and all of the dimensions do that. Except for two of them. The two special ones are mass and tone. Mass will start at octave one and just increase all the way up the cycle to the end. And the same with tone. And tone is a little more, tone, even though we don't necessarily hear the tone until it comes into the range of our human ears, what our human ears can sense, it's still there. Everything um, has a tone. So starting from the very first octave, where the tone would be extremely low, and going all the way up to the 10th octave, where the tone would be extremely high pitched. That just is a continuous, change. And so it doesn't repeat. It only repeats once the whole cycle repeats. So that's kind of the interesting thing about tone and mass. Those are the only two that do that. All of the other 16 ones will repeat. Okay. So, all right. So let's talk about tone. I want to read a few things from the universal one about tone. Uh, so tone is the 17th dimension. Um, and Walter starts by saying, tone, in the sense in which we understand the meaning of the word sound, is one of the great dimensions. Tone is registered in sound as it is in color, plane, temperature, and other dimensions. Every expression of energy has its own particular tonal sound, just as it has its own color, plane, or degree of temperature. Sound is generally conceived to be the result of a concussion taking place in the air. The ether of space is generally conceived to be soundless. This concept, and let me just say, for a lot of traditional science will think of when you leave the earth and go out of the earth's atmosphere way out, they think of it as a vacuum, that there's no air, there's no nothing. So they think of it as soundless. But Walter says this concept is not in accord with the laws of motion. Sound is from the beginning and from the very first octave. It matters not how low or how high the potential. Every active and reactive oscillation is accompanied by sound. Sound increases in resonance as potential accumulates. Both effects of motion are due to the same cause, the generation of accumulated energy from the first to the 10th octaves and its radiation into inertia. So, he says that all sound is caused by potential impacting against potential or separating from potential. Okay. And all sound is the result of explosions of accumulating or redistributing energy. Every generative action and every radiative reaction is an explosion. All explosions are either generoactive or radioactive. And, that's when we talk about, gravitative or radiative, either coming together or exploding apart. The general active explosions are caused by the desire of positive charge to accumulate as mass. The radioactive explosions are caused by the desire of negative discharge to redistribute accumulated masses of stored energy into a state of inertia. So, and I'll have to admit, sound, this even though it is one of the great dimensions, it's pretty simple. And I think this is one of those dimensions that, when you talk about it, people already, we're all familiar with sound, and we're all familiar with the idea of, like a piano having different keys on the keyboard. And, many of us are familiar with the concept of the octave on the piano keys. So but I'm going to bring up some, some more visual. The one that I want to share. Okay, so we've seen this one before this is our two cubic wave fields, and we see our spirals in there. And we notice how the spiral from this one is heading up. We see our good old, 1, 2, 3, 4 and 4, 3, 2, 1 in terms of the locked potential positions, from the formula of the locked potentials. So when Walter talks about, accumulating mass, he's talking about it going from this plane and spiraling up to the 4, 4 position. And so it just depends where you are along that journey, what your potential is. So we all know that, something at position, I'll start over here on the plus side, something at position +1 has its own potential, but something at position 2 or 3 is going to be higher potential. Okay. So there will be a unique sound for things that are at this potential. And as the potential raises, there's going to be a higher pitch sound. Okay. So 2 will be a higher pitch than 1, and 3 will be a higher pitch than 2. So that's kind of the three-dimensional. Okay. So this is from the Walter's book, Atomic Suicide. And so this is a great diagram because at the top here, he's showing in a linear fashion the cones. Okay. And so this would be the base of the cone that we just saw in 3 dimensions in the cubic wave field. And this would be position 1, 2, 3. And then in the middle would be the 4, 4 position. All right. Does that make sense? And down here, he's showing the same thing where these rings. Oh, and gosh, I'm sorry. We haven't talked about the rings that way. So, but that's not what that's not what I'm trying to show today. What I'm just trying to show is that the different potential positions will, of 1, 1, 2, 3, and 4 will coincide with color, like we talked about last time. Each one will have its, red, violet, red, orange, yellow. then green, blue, blue, violet. But so today, he also down here puts notes, musical notes. So once again, each potential position will have its own tone. And here he's got like the scale do, re, mi, fa, so, I guess. And for those of you who read musical notes, anyway, this is a musical staff and it just shows musical notes going, up in pitch every step. And that is corresponding to the formula of the lock potentials positions. Position one, position one, he's got D. Position two, he's got E. Position three, he's got F. And then position 4, he's got G. So that is essentially the connection of sound. This is once again our periodic table that we talked about with color. And we can see how the color patterns repeat. But we have to just imagine in terms of sound, each of these colors would be a different pitch. But as it's going up, instead of repeating, it's just going to keep getting higher and higher pitched, just like you go up the keyboard. Now, the interesting thing is that even though the tone can, or the sound, the pitch of the sound, or the pitch of the note keeps going higher, the notes actually repeat in terms of, so to be a little more technical, sound as we hear it and with our ear, it is a vibration of, of the air. And each sound corresponds to an exact frequency that air is oscillating. And now I know this just because I'm an audio engineer, but like our human hearing, we can hear oscillations of about 20 hertz, which is 20 cycles per second. Is cycles per second is hertz. So we can hear the air if it vibrates back and forth about 20 times per second. That's about as low as we can hear. That's a really low bass sound. Okay. And we can hear all the way up as high as about somewhere between 17,000. They're called kilohertz, because that's 1,000 hertz. So anywhere we hear up to, well, I'll just keep it in hertz. Our lowest is around 20 hertz. Our highest is around 20,000 hertz. Interestingly enough, as we get older, our sound gets worse, our hearing gets worse, and it gets worse on the ends. Like we start to not be able to hear the higher pitch frequencies and we start to not be able to hear the lower pitch frequencies. So and I always remember this when I was young and I walked into a store with my mother into an a department store, and I could hear this really high pitched sound. I was like, Mom, what is that high pitched sound? And she couldn't hear it because she was old enough that she couldn't hear. And it was probably around an 18,000 hertz sound of whatever it was, the lights or something. I don't know what it was. This was a long time ago. And so it's the same thing, like a dog can hear higher than 20,000 hertz and we can't. So the dog whistle will vibrate at 20,000, higher, like 22K or 22,000 hertz or something like that. Anyway, so as all dimensions, it's just an illusion of motion. So it just depends on your own perspective, whether or not you can perceive it or not. So same with sound or tone. We can only hear that small range between, 20 hertz up to 20,000 hertz, but it keeps going in the, millions of hertz or, the 1 hertz and below, fractions of a hertz. If we think of a keyboard, if everyone can think of like a piano keyboard, and I'm going to kind of compare it to this chart here, each one of these would be a note, a different key going up the keyboard. And if this is A, B, C, D, it'll go E, F, G. It repeats so that over here, this will be an A again, but it'll be in a higher octave. So just as the keys on the piano will repeat as you can hit a low A or you can hit a higher A in a different octave. And the relationship of the frequency is that if A is at 440 hertz, well, when you double that frequency, that's how you get to the next A in the next octave up. And then when you double that frequency again, you'll get to the next A in the next octave up. So, and that's directly, with the formula of the lock potentials and the elements, and the potential position, because each potential position has its own tone. So, so that's essentially, I hope you guys are seeing, that's essentially how sound or tone combines with all the 18 dimensions. Now we haven't studied all of them, but the ones that we have studied, like we can understand that. So, for example, we know that temperature will increase as you are increasing in potential. And then it will decrease as you're decreasing in potential. So now we know that tone will increase in pitch as the potential increases. But the interesting thing here is, like, say, if you're at silicon, if the potential starts decreasing here, the tone is still rising in pitch. So that's kind of the one interesting thing about tone. Let's see. Now I want to read a few other kind of interesting things about tone and sound that he describes. Let's see. So he describes how he says the explosions in the low potential position of the first six octaves are registered in the elements as full tones. Each full tone of sound is a whirlpool formed around a central nucleus or vortex, toward which the generative energy induced by the effect of the explosion rushes with increasing violence, and away from which the reaction to that explosion rushes with decreasing violence. Let's see here. When the energy accumulates to the high potential positions of the sixth and seventh octaves, the tonal explosions take place as full tones from, and actually, let's follow on the chart here. Right. So here's the sixth octave here. So he says the tonal positions, are full tones until, let's see, until you get to the +3. I guess this would be the orange little ball right here, the +3 position, and also the -3 position, this green one. Now, he says that at these points, the accumulation of generative and radioactive force is so great that 5 mid-tonal vortices are formed between those positions and the overtone of the wave. So in between position 3 here and the overtone is cobalt here, you'll see, so let's see, we've got potassium is the first tone, calcium is the second tone, and scandium is the third tone. So in between scandium and cobalt, now you have these 1, 2, 3, 4, 5 tones that are, they're like, he calls the mid-tones. Okay. And same on the other side, you got nickel, copper, zinc, gallium, and germanium in between cobalt, which is the 4 4 position, and arsenic, which is the number 3 position. Let's see here. And that same thing happens as we go even higher to the 7th and 8th and ninth. And the higher it goes, the more midtones you're going to have between position 3 and position 4/4. Sound emanates from the explosions of every potential, no matter how low or how high. More than this, the sound from either general active or radioactive explosions register themselves in every octave, both higher and lower than the octave of source. Now, that is actually pretty significant because this is one of those things where it's like if you hit a key on a piano, it will instantaneously have harmonics in higher and lower octaves. And this is one of those things that goes with his whole concept that like everything is connected, that it's like an action will have an instantaneous like it's like the rest of the universe knows about that action instantaneously. It's still the thing that blows my mind the most about his concept because it just seems like what? That's like action faster than the speed of light. It's like action at a distance, like immediate action at a distance. But hey, I'm just here telling you what Walter Russell's concept is, and this is what he is saying. He is saying everything is connected instantaneously. So take that for what it is. And, because he talks about how we have 2 universes, the one universe of motion and the other universe, which is of non-motion. And he's essentially saying that in the universe of non-motion, every point is the same as every other point. So therefore, as something happens at one point, it happens at every other point at the same time. So that's just kind of the whole idea of a universe that has no motion, no dimensions. It's just timeless and spaceless and infinite and no beginning, no end, infinite, and it's everywhere all at the same time. So and that is like the neutral point or of inertia. That is like where motion starts and stops. Scott, I have to say, I listened to the Dale Pond video that you sent me. Dale Pond is one of my guys, like one of my heroes. He's a guy who really has been studying this kind of stuff. Walter Russell. He's big into John Keeley and other scientists, but he's been studying this for like 50 years. And he did a great video on the actually the link is, I'm sure the link is in the group, or at least Scott sent it to me. I should put it in the group because I watched it and it was actually pretty inspiring. But he explained how Russell and Keeley, they're both saying the same thing. They use some different words, but they're describing the same thing. That there's this 0 point or point of stillness, and that's where like all the power comes from. And throughout the waves, there's always as Walter liked to call it, the fulcrum or the still point, as if, the wave is waving back and forth like a seesaw going up and down. Well, you got 2 kids on the seesaw going up and down. There's always the fulcrum in the middle that's not moving. So any kind of motion or wave motion, there's always a 0 point of fulcrum that's not moving. And that's, how Russell described that is, the universe of God, the mind of God, and it controls all motion. It's inside the very middle and it's outside surrounding the motion. And we'll get more into that later when we talk about the cubic wave field. But so bringing it back to, let's see how much time we have left. Got to keep an eye on. All right, we've got about 1 minute. Bringing it back to music, and this is the last thought, and then we'll then we'll sign off and come back on. So when you hit one note on the keyboard, it's instantaneously known throughout the rest of the keyboard through harmonic interaction, and we can hear that when we hit a note on the keyboard. Okay, so I'm gonna shut it down, guys, and then we'll log back in. So continuing our talk about the 17th dimension of tone. There's a few more things I want to read to you guys from the Universal One. Let's see here. Oh, right. So we left off saying that, all the explosions travel both ways up and down the octaves. He says, for there can be no action without a corresponding reaction, nor can there be a reaction of an action without a repetition of both. This is a universe of reproduction, and any effect of motion runs the entire gamut of all effects of motion. The force of that which is running away from inertia is equal to the speed of that which is returning to inertia. And the speed of one is very great and its force very little. On the contrary, the force of the other is very great and its speed very little. And that's kind of, we see that in, we talked about time before. We talked about the relationship between axial rotation and orbital revolution. And that's kind of another thing that just goes with that, where, and the example is, say, for example, Mercury, which is the closest planet to the sun, it is revolving around the sun very fast, but it's the way that it rotates on its axis is very slow. Now we contrast to, as we get further out, like say to Jupiter, now the orbit around the sun is very slow, but the spin on its axis, is very fast. And so that's kind of that same thing that he's saying here. Okay, Scott, I see you've got your hand up. You got a question?
Yes. So on tone, when we're talking about tone, would you classify that as a pitch or cycles per second? How would you define each element's tone?
Sure. Yes, you're right on both of those. It is a pitch, and it literally is cycles per second. And we don't hear all of the tones because they're outside of our hearing range, but the ones that we do hear is definitely cycles per second. And, it doesn't matter. I mean, we're most familiar with air, but you can still hear sound when you're in water. You can, if you're in a swimming pool or the ocean, you go underwater, you can still hear sound underwater. In that case, it's just the water is the medium that is oscillating. So once again, it's still cycles per second or
So
frequency.
what would
Yeah.
be, let's say, carbon cycles per second in air?
Oh, that's a great question. Let's see. How could we figure that out?
It's okay if we don't have to figure it out now.
I
Just
don't,
like,
yeah, I don't know the answer, like just
yeah,
off the top of my head, but like
we can
that,
put it in the
right.
back burner.
That is something. Hold on 1 second. I actually can tell you, I can give you some examples, because in the Universal One, he does actually list the,
Cycles per second?
oh, wait. Oh, never mind. No, I think that's temperature. I think he lists temperature. Yeah, it's not cycles per second. It's temperature that he lists. But yes, but just like every element has its melting point, say for example, or its freezing point, it also has
It's mass, its density,
its
all
tonal
those. But we need to figure
frequency.
out what is the CPS for each element.
Oh, cycles per second.
So we know what the mass is, what the density is, what the temperatures are, right?
Yes,
For each of the elements. I just
right,
want to be able to calculate the CPS for each element as well.
right, and that's cycles per second when you say
Yeah.
CPS. Okay, just making sure. Okay.
Yeah.
Yes, yeah, exactly. And yes, you can. Like you literally should be able to calculate its color So you'll have a frequency of light and its tone. You'll have a frequency of its tone. Yeah, that's right. And so, we're seeing how all these dimensions are related together. And by the end, like once we've described all 18 of them, Walter says beyond those 18, there are no more dimensions of motion to measure. And, who am I to, I'm just going to believe him, I guess, until I can find something new. But he's essentially saying once we know all of those, that then we'll have some super insight to things. And once we get to the universal mathematics, this is one of the things that I want to try to do. I want to try to use train an artificial intelligence on Walter's stuff so that I can chart some of these relations of like all these relations. And Walter talked about, he said he's giving us this, but he said it's up to the ingenuity of man to be able to then, he said once all these things are charted, we'll be able to understand a lot more. And he didn't have time to chart them all. He was like writing down all the fundamentals for us. But he's given us enough that, we can now chart. And I don't know about you, but I was like, oh my gosh, that's like, it seems impossible. But now with AI, I feel like I could do it. So that's going to be one of the projects that I want to try to do. Um,
If you tell me the formula for the CPS per element, I'll make a table for all of them.
right. Okay. All right. Then I will be in touch with you. We could, cause yeah, I definitely want to do that. Let's see. Okay. So a couple other kind of rules and things here. Let's see. Oh, yeah, he says right here. So, when measurements of tonal positions are made possible and correlated to plane, color, temperature, and other dimensions, a higher and more complex chemical analysis than that of today will be made possible. The simple modern chemical analysis of a grain of wheat will not allow a synthesis which will enable one to produce the same substance. The more complex chemical analysis of all of the dimensions which enter into that grain of wheat will make it possible to reproduce exactly that substance, even to the retaining all of its attributes. That is like blew my mind. What's up, Scott?
Star
Question?
Trek replicator.
Right. Yes, exactly. The holodeck. That right. That is how we get to the holodeck. If we know all the dimensions of whatever substance we're trying to make, then we should theoretically be able to create machinery that will raise or lower potential to be able to repeat all of those dimensions of motion in the proper, configuration and like proportional ratios. So yeah, I mean, he's like letting us know right there. So, I was pretty excited about that. Let's see. I guess I'll read this just so they're on the record here. Oh gosh, yes, and here is okay. So now, just to let you know, I've been reading Walter's Universal One for a long time, and I have found what I think are several typos where whoever, I don't know if it was just Walter got it mixed up or whoever published it did, but this is one of them coming up here, and I'll point it out after I read this other part here. And uh, he says, just as high potential discharges into low with ever increasing speed of reproduction, so does sound raise its tone and increase its reproductive speed. It also decreases its wave dimensions as potential powers. So, what he's kind of saying there, this is my understanding of it, is that, and I'm going to share the screen to give you a visual along with this. So, we're talking about, so here is, Now this is the 9 octave cycle from Atomic Suicide. But from the first octave, one, two, three, four, five, six, seven, eight, going all the way up to the ninth octave, um, every potential position here is it's in its own octave. Okay. It's in its own wave field, its own cubic wave field. And so each one will have dimensions of length, width, and height. Okay. And so what he's saying is like the lower um, octaves, the pitch will be much lower, and the wave dimensions, like the length and width, will be much bigger. You can imagine how, and so if we talk about pitch, it's going to be low pitched down in the low octaves, and then it's going to go up to high pitched in the high octaves. And just like with musical instruments, for example, like you can imagine a very big bass, is usually a larger instrument because it needs like the big long string to be able to vibrate slowly. Whereas instruments that are very high pitched, like maybe the flute or the piccolo, if you guys know what a piccolo is, it's even smaller flute. That thing can hit the super high notes, but those high notes, the dimensions of the wave are going to be shorter. So that's what he was talking about when he was saying, just as high potential discharges into low with ever increasing speed of reproduction, so does sound raise its tone and increase its reproductive speed. It also decreases its wave dimensions as potential powers. So he's saying like the wave dimensions get smaller as the potential is rising up, or the tone is rising higher and higher in pitch. Let's see. Now, I don't even know if I should read this. Gosh, I think I am going to. What I was saying earlier was that I've read this book a lot, and I think that there are some typos in here. And I remember when I first read this, I was thoroughly confused. And it wasn't until years later that I was like, I think he just switched this up. But I'm going to read this, and you guys can tell me what you think. He has these two rules here. Rule number one, he says, in any mass, the lower the octave, the higher the potential, and the slower the speed of reproduction of any effective motion. And the next rule is, in any mass, the higher the octave, the lower the potential, and the greater the speed of reproduction of any effective motion. Now, I was confused by that. I really think that they flipped the word higher and lower. This is what I think it should say. And I'm going to read the same thing, but I want to get this on the record. The way I think it should be is, in any mass, the lower the octave, the lower the potential, and the slower the speed of reproduction of any effective motion. And then the next rule, which I think it should say, is, in any mass, the higher the octave, the higher the potential, and the greater the speed of reproduction of any effect of motion. So I just wanted to get that on the record. I think that they switched the word higher and lower because from everything else that I read in this book, that's what it seems like it could be. But I could be wrong. Because I know for sure there was when I very first started reading this book, I thought there was something wrong. And it was years later that I went back to it and I was like, wait, that's not wrong. That's correct. So, this could be one of those things. I don't know yet, but I wanted to put it out there just because that was one of the things that
I mean,
so
you
if
can
you
always
ever,
take your findings to Darren.
yes, yeah, I have talked with him about typos or mistakes in the universal one, and he did acknowledge. He said, "Oh yes," he said there are mistakes in there. So I was like, "Oh okay." I thought it was just me, but So anyway, let's see. So I think that's generally it. Like actually, this chapter on tone is quite short. Even in the Universal One, it's like literally 3 pages, I think. So and it's something that we all kind of understand. Tone and how you've got low, like the low bass sound is lower frequency. Okay, its cycles per second are lower. It's oscillating slower. And as you go up pitch, the pitch gets higher, the frequency gets faster. It's oscillating faster. If you're starting low, every time you cut a wavelength in half, that means you've gone up 1 octave. And we can see that in terms of like a vibrating string, like on the guitar. There is a point on the guitar. That's something, if you guys are interested, there's like plenty of that on YouTube or whatever. You can look up like frequency and wavelength and how it's related to pitch or tone or sound. It's pretty common. But it's just another dimension that we can, you know, that we can connect with the other dimensions. And it's things, these are things like, especially with sound, are things we like take for granted. Like if you had, say, a tea kettle that had one of those little whistles, you can almost hear like the water boiling, like you could hear like the pitch of it going up as it gets faster. And when it gets to that certain boiling point and then that whistle blows, there's a lot of things like that. If you pay attention to sound, that you'll see everything has its own sound and it's all related with the speed of oscillation or the frequency, how frequently it oscillates back and forth. So yeah, so tone, and it just so happens that tone just raises through the entire cycle of the periodic table, along with mass. Those are the only two that go all the way up, but everything else just repeats every octave. Yeah, so that's it in terms of tone. There's some other interesting things that Walter says about sound and how it travels through air. And I'm surprised it's not in it's actually in another um, it's in another chapter, which I don't remember which chapter it's in, but he talks about the human voice and how it is um, a gravitative sound because it's bringing things together from your body into the voice, and then when the sound comes out of your mouth, then it turns radiative and then it expands out. We can hear that sound when it's like, say you're close to someone talking, but if you're, say, out in nature and you're like there's a big canyon or something and there's like a mountain very far away, he talks about how the voice will expand and then it will expand so wide that you won't be able to hear it. But then as that wide, expansive, radiative um, light or energy or sound gets to the midpoint between you and the mountain, then it starts to compress again, and it will then compress and hit the mountain. And by it hitting the mountain and compressing, it's compressed back to a level that our ear can hear it. And so that is why we then hear an echo that bounces back to us. And I thought that was very fascinating. And he talks about how, oh gosh, am I going to get this right? Well, I'm going to paraphrase here, and I'll have to look this up later. But there are some aspect in terms of like he said that the sound that's going through the air might take, you know, several seconds for you to hear the echo. But during that time that the sound is like running through the air, there's another um, part of that light energy or something, he said, that would go around the earth like two or three times before that, sound that's going through the medium of the air would hit that uh, mountain. And I think it has something to do with light versus sound. Of that action of your voice, there's light, but then there's also sound that's traveling through the air, which moves at a different rate than the light would move. So I think I kind of got that right, but I'll have to find that, or if you guys are ever reading the Universal One and you come across that, I just wanted to say that because it's kind of a fascinating thing. Um, so I think we have some time left today. Do we have any questions or anything that we want to talk about? Oh yeah, we got 10 minutes left in the meeting. Okay, we've got about 10 minutes left in the meeting. And I usually ask you guys in the beginning if there's anything you want to talk about. I guess I didn't today. So just, did you guys have any questions or anything you wanted to talk about other than, or any questions on this, on tone? Okay. Okay. I was just asking if you had any questions.
If no one has a question, I have one.
Oh, okay. Yes, please go ahead, Kirsty.
So, um, so Walter says that space travels with its solids, but each solid is surrounded by a minus zero, equal and opposite vacuity of the plus zero, which we call matter. So matter floats in these insulating spatial counterparts.
Yeah.
And a positive electricity is accountable for the solids and negative electricity is accountable for the space. So um, I'm just wondering, like, for example, sodium, it's not surrounded by a bubble of chloride, is it? It's surrounded by a bubble of negative sodium or
Okay.
chlorine. Is that the opposite of then? So what is the opposite of fluorine?
Oh,
Sodium and
okay.
fluorine. Okay, so when sodium is gravitated together, what is surrounding it? Because it's not surrounded by fluorine, is it?
Okay. Great question. So when he's talking about matter and its surroundings, he's talking about polarity. He's talking about like that things start at an equilibrium, and then as they start getting wound up, so like sodium has started to get wound up, the light has come together some. Now, not very much because sodium is just the first position, right? But some. Um, he's just saying that matter that's there, that sodium, that is like plus equilibrium. And that because that matter came from somewhere, it's been kind of sucked into this vortex. So it was kind of out here. And once it got sucked into the vortex, and now there's more of it here at sodium, so that it's plus equilibrium. And he's saying that out there, there's less of it. So it's minus equilibrium. It was when it started, it was at equilibrium. But once it started pulling stuff together, then you got this polarization of more stuff here in the middle and less stuff surrounding it. Because basically the force of gravity, that vortex, it kind of stole the stuff from where it was in equilibrium. It stole the stuff from there and brought it to this one smaller space. And so
then it simultaneously created fluorine on the opposite side of equilibrium, but we're saying that the negative space around sodium is not this, not fluorine. It's just negative. It's negative sodium. It's negative space sodium. It's the vacuum. The vacuum.
Well, okay.
Well,
So actually, it wouldn't be. Wait, where am I? Where are we? Oh no, no, that's correct. Sorry, I was thinking of chlorine. No, right. So right, this is the zero. Neon. Wait, you guys still see my? I'm still sharing my screen, right? Okay. So I was saying you're still seeing the colorful periodic table here, right?
yep, I can see your screen.
Okay, great. Okay, so right. So yeah, neon is the equilibrium where it
Yep.
starts. Right. And so since it made the plus over here at sodium, it's made the minus over here at fluorine, right? So
hmm
you're saying your question is like what is surrounding sodium, I guess?
What gets
Right.
so fluorine is simultaneously created when like sodium and fluorine are complete opposites of each other, right? And so
Right.
when one is created, the other is created to maintain equilibrium. And he's just saying that yeah, so what's surrounding fluorine as well? Like he's saying space travels with its solids. So
Now,
so is what is the space that's traveling with the solids?
right. So
It
so
doesn't have a name.
theoretically it's all light, right? And just different concentrations or decentrations of light, like the things that are above equilibrium versus below equilibrium. And
hmm
that's my understanding of it is that yeah, like there we don't have a name for kind of the light that's kind of around there. So here's something because you're kind of I was at the same point and this is one of the things that actually I just was reading today. So if we imagine at neon being the plane, and you're going to have when the motion starts, sodium and fluorine are created, at the same time. Now, it's a process going from step one to step two to step three to eventually the perfection of the circle at 4 4. But during that journey, when hold on, when things get to silicon, there's a perfection, there's a perfect circle. Okay. Um, but on that journey going from plane to sphere, perfection of sphere, all these intermediate things are Russell describes them as imperfections. Like their orbits are not quite perfect. Like when something's a perfect circle, then orbits like everything is perfect. Like then the space around it, like the cube around it will be a perfect cube. The orbits of say any planets that form there will be a perfect circle um for a short time. But he was saying that during that journey from plane to sphere, oh, thank you, Scott. 1 minute. During that journey from plane to sphere, there are just many imperfections. So we don't have names for some of those imperfections, the things that are in between sodium and magnesium, or in between fluorine and oxygen, or what's around fluorine, or what's in between fluorine and sodium. Well, we don't have a name for them yet. I mean, all I could say is that it's light. But that's a great question. And one of the things I think we should delve into deeper, as we get further down in our journey. So that's the best answer I have for you right now. So, all right, guys. Well, it's been great. I think we're about ending. So goodbye. We'll see you next time, probably 6 p.m. next Saturday. All right. See you later.